All right, so I just figured I would go over the SAT problems in case any of you were curious how to do them. So here we go. The first one gives you this equation, x minus 1 over 3 equals k, and k equals 3. It says, what is the value of x? So basically, you're just taking k equals 3, and you're plugging it in for k. And then you're going to solve for x. So to solve this for x, we need to get rid of this 3 here. That's divided by 3, so you need to multiply by 3. So then you have x minus 1 equals 9. And then lastly, just add 1. Whoops. So x is 10. So that one should have been D. Number 1. Here's number 2. This one talks about Kathy being a repair technician for a phone company. So it says the number of phones that she has left to fix at the end of each day can be estimated with the equation. So 108 minus 23D, where P is the number of phones left and D is the number of days she's worked that week. So it asks, what is the meaning of the value of 108? So she does 23 per day times D days, and you're subtracting that from 108. The 108 represents that she starts each week with 108 phones to fix. So number 2. Here's number 3. I thought this was cool because we learned this year. So remember with complex numbers, when you have just like a regular integer and then an imaginary number, you just combine the integers and then combine the complex numbers. So it's going to be 7 plus negative 8 is negative 1. And then 3i plus 9i is 12i. And that's it. Letter A. Number 4, we did a version of this. We did like adding and subtracting polynomials. This one is like more complicated than the ones that we did, but I figured you guys could try it. So this negative here, this is subtraction, remember, has to be distributed out here. So this is going to change to plus, and then all of these signs change. So this is now positive, that one's now negative, and that one's now positive. And then you just combine like terms. So this is x squared y. So you want to look for another term that has x squared y, which is here. This is just y squared, negative 3y squared, and positive 3y squared. And then xy squared, xy squared. So first I like to identify the like terms and then combine them. So x squared y plus x squared y, you just add the coefficients, which are 1. So that's just going to be 2x squared y. So those are gone. Now negative 3y squared plus positive 3y squared, those would cancel to 0. And then lastly, 5xy squared plus negative 3xy squared would be 2xy squared. And that's it. So that one was C. Okay, next we did ones like this, solving by square root. What is the value of t? So you would add 4. So t squared equals 4, and then take the square root of each side. Technically, it's plus or minus 2, but this says that t is greater than 0. So that eliminates the negative, and t is just positive 2. That one. Okay, a couple more. Number 6 was a geometry question. So I don't know if you guys remember anything about this, but it says that L and M are parallel, and so are S and T. So it says if the measure of 1 is 35, what is the measure of angle 2? So for this one, you would use like either corresponding angles or like alternate exterior angles, stuff like that. So like this one and this one are both going to be 35. And then because they're corresponding, if you guys remember that from geometry, and then this one and this one would also be 35 because they're corresponding. And then these are called a linear pair. So you do 180 minus 35, which is 145. Okay, and then this one says the complete graph of the function f is shown in the xy plane above. For what value of x is the value of f of x at its minimum? We learned this year too. So f of x is just the whole line. So here's the minimum. Okay, this ordered pair is -3, -2. But we want the value of x. Remember, anytime you were giving like intervals, you always use the x value. So the x value is -3. So this one was B, -3. Okay, last one. So you were given this quadratic and asked to figure out how many seconds it would hit the ground. Now, this was the SAT problem. I added in the hint to use the quadratic formula because I didn't know if you guys would remember that. Obviously, when you take the SATs, I'm pretty sure they give you the quadratic formula like on your formula sheet, but if you didn't know to use the quadratic formula, remember anytime it's asking for when it hits the ground, you're solving it because you want to see like when it's going to hit the x-axis. So if you remember how to do the quadratic formula, you identify your A, B, and C. So A is going to be negative 4.9, B is going to be 25, and since there is no C, it's 0. So then you just plug in. So negative B, so negative 25 plus or minus big square root B squared minus 4 times A times C all over 2A. So that's taking this, plugging it into this. Okay, now if you remember how to simplify the quadratic formula, this is going to be negative 25. So 25 squared is 625. And then negative 4 times negative 9 times 0 is 0. I don't care what these multiply to because once you multiply that by 0, you just get 0. So really, you don't even have to write that. And then 2 times negative 4.9 is negative 9.8. Okay, so now we have to take the square root of 625, which is going to be 25 because we just got the 25 squared was that. So it's going to be negative 25 plus or minus 25 over negative 9.8. Then remember, you have to do the plus and the minus. So we'll do our positive one that way and our negative one that way. So negative 25 plus 25 over negative 9.8, and then negative 25 minus 25 over negative 9.8. So if you add the top, that's 0. 0 divided by negative 9.8 is 0. Negative 25 minus 25 is negative 50. Divided by 9.8, you get 5.1. So your options for the answer, 5.1 was not an option because it said approximately how many seconds. So 5.1 is closest to 5. That would be that one. All right, so that's that. Let me know if you have questions. I'm going to have you do some more today and then probably a few more on our last class. All right, have a great day.